As we move beyond the limits of current wireless standards, the conversation is shifting. We are entering the era of 6G, where connectivity is about more than just speed. The paradigm is evolving from maximizing raw throughput to prioritizing the quality, relevance, and utility of every bit transmitted across the network. This new approach is centered around the X of information continuum, a framework designed to quantify the multidimensional value of data in real time. To build truly intelligent systems, we must optimize across four critical dimensions: temporal freshness, semantic quality, security reliability, and network deliverability. These aren't isolated metrics. They are deeply interdependent, working in concert to ensure that 6G networks can support the most demanding modern applications. Let's start with timeliness. In a world of autonomous systems, the age of information is often more important than the volume of information. Age of information, or AOI, quantifies freshness. It measures the time elapsed since the most recent update was generated, ensuring real-time responsiveness. By monitoring peak AOI, 6G networks can establish worst-case staleness boundaries, which is vital for safety-critical applications like remote surgery or traffic control. But freshness alone isn't enough. The network must also account for correctness, ensuring that decision-making systems never rely on outdated or invalid data. Moving to the second dimension, quality and utility. This is about understanding the semantic meaning and the practical value of every transmission. Semantic communication allows the network to interpret the purpose of data. It filters out the noise and focuses on what truly matters for the task at hand. Utility-driven metrics evaluate how information improves decision-making, allowing 6G systems to prioritize high-value data flows over routine updates. Every bit of intelligence comes with a cost. We must balance the gains in utility against the expenditures in energy, bandwidth, and computational power. The third dimension is reliability and security. In an era of AI-driven networks, trust is a fundamental requirement, not an afterthought. Security of information protects against adversarial threats, ensuring data integrity and confidentiality through adaptive, multi-layered defense mechanisms. Entropy metrics help us quantify uncertainty. By understanding the randomness in our measurements, we can build 6G systems that are more resilient and predictable. Survivability measures the network's ability to remain functional despite partial degradation, ensuring that essential 6G services never experience total collapse. Finally, we have network delivery. This dimension ensures that the information substrate is optimized for robust, low-latency reachability in dynamic environments. Deliverability metrics assess the probability of successful reception across changing topologies, which is crucial for high-speed mobility in 6G. Redundancy control balances the need for robustness with the cost of overhead, ensuring we have enough replication to prevent failure without wasting resources. Relevance metrics prioritize content based on task-specific utility, ensuring that critical data always receives the highest priority in a crowded spectrum. The true power of this framework comes from the integration of artificial intelligence. AI allows for adaptive, context-aware optimization of these competing objectives. Techniques like deep reinforcement learning enable 6G networks to navigate complex trade-offs, automatically adjusting priorities based on real-time feedback. In the 6G ecosystem, agent-to-agent communication will be driven by intent and semantics, enabling machines to collaborate with unprecedented efficiency. We can see these metrics in action within autonomous transportation. Here, timeliness and security are mission-critical for safe, real-time decision-making. Digital twins also rely on this continuum, requiring perfect synchronization between the physical and virtual worlds to enable accurate simulation and control. In the industrial Internet of Things, multidimensional metrics ensure that every automated process is optimized for reliability, energy efficiency, and safety. Federated learning further distributes intelligence across the edge, preserving privacy while continuously refining the network's understanding of information quality. As 6G matures, the X of information continuum will serve as the foundation for a truly intelligent, value-aware communication infrastructure. By focusing on what information truly means and how it can be used, we are building a network that is faster, smarter, and more trustworthy than ever before. The future of connectivity isn't just about moving bits. It's about moving the world forward through the power of information. Welcome to the 6G era.